Welcome to the complete A2 Cambridge Physics 9702 exam guide. You have 2 papers to pass. Paper 4, worth 100 marks over 2 hours, covering core A2 theory plus 1 optional topic. And Paper 5, worth 30 marks in 1 hour 15 minutes, testing your practical skills, planning an experiment and analyzing data. This video will walk you through everything: the 14-day plan, every topic that always comes up, the formulas you must know, how Paper 5 works, and exactly what Cambridge means when they say describe, explain, or state. Let's get into it. Here is your 14-day battle plan. Week 1 is entirely dedicated to Paper 4, Section A, the core topics that appear every single year. Day 1, gravitational fields. Day 2, thermal physics. Day 3, simple harmonic motion. Day 4, electric fields and capacitors. Day 5, magnetic fields and electromagnetic induction. Day 6, quantum physics and nuclear. Day 7, a full-timed Section A mock. Mark it and find your gaps. Week 2 shifts to optional topics and Paper 5. Days 8 through 10 cover astrophysics, medical physics, and electronics and communication. Days 11 and 12 are entirely Paper 5. Learn the planning template on Day 11, master analysis and graph work on Day 12. Day 13 is a full-timed mock of both papers. Day 14 is your final drill. Fix what went wrong, review your formulas, and sleep early. Every day, 2 hours of new topic study in the morning, 2 hours of past paper questions, then mark and review in the afternoon. That cycle, study, attempt, mark, is what actually builds exam skill. Gravitational fields is question 1 on Paper 4. Every year, no exceptions. There are 3 things that always come up. First, the gravitational potential graph. You must know that phi equals negative gm over r. The curve is always negative, starts very negative near the planet's surface, and rises towards 0 as r increases to infinity. The negative sign is not optional. Get it wrong, and you lose every mark on that question. Second, Kepler's third law derivation. You combine gravitational force equals centripetal force. That's gmm over r squared equals mv squared over r. Then substitute v equals 2 pir over t, and simplify to get t squared proportional to r cubed. Cambridge loves asking you to show this. Third, orbital speed and escape velocity. Orbital speed is the square root of gm over r. Escape velocity is the square root of 2gm over r, exactly root 2 times the orbital speed. Know why? Escape velocity comes from setting kinetic energy equal to gravitational potential energy at infinity. 2 more core topics that appear every year: simple harmonic motion and thermal physics. For SHM, the definition you must write from memory is acceleration equals negative omega squared times displacement. The negative sign tells you the acceleration always points back toward equilibrium. That is what makes it oscillatory. The maximum velocity is omega times amplitude. It occurs at the center where displacement is 0. For energy, kinetic energy equals a half omega squared times x naught squared minus x squared. Potential energy equals a half omega squared x squared. And total energy equals a half omega squared x naught squared. This is constant. It does not change with displacement. A very common exam question is to sketch these 3 on one graph. Total energy is a flat line. KE is an inverted U. PE is a U shape. For thermal physics, the ideal gas law is PV equals nRT, where N is moles. The kinetic theory result is a half mc squared equals 3 halves kT. This links temperature to the mean kinetic energy of a single molecule. The first law is delta U equals Q plus W. Be careful with sign convention. Work done. On the gas is positive. Capacitors and electromagnetic induction both appear every year. For capacitors, the 3 energy formulas are interchangeable. Energy equals a half QV equals a half CV squared equals Q squared over 2C. The discharge equation is Q equals Q naught times E to the power of negative T over RC. The time constant tau equals RC. This is the time for charge to fall to 37% of its initial value. A very common question asks you to explain why the discharge is exponential. Here is the answer chain. As charge decreases, the potential difference decreases. Lower PD means lower current. Lower current means the rate of charge loss decreases. A rate of decrease proportional to the quantity itself gives exponential decay. That chain earns you full marks. For electromagnetic induction, Faraday's law states the induced EMF equals the rate of change of magnetic flux linkage. Lenz's law states the induced current opposes the change causing it. This is a consequence of energy conservation. Always use Lenz's law to determine direction before applying the right-hand rule. Quantum physics and nuclear. These appear in Section A every year and can also appear in optional topics. For the photoelectric effect, a single photon is absorbed by a single electron. The photon energy is hf. If hf is less than the work function phi, the electron cannot escape, no matter how intense the light. This is why there is a threshold frequency. Above threshold, hf equals phi plus a half mv squared. The leftover energy becomes kinetic energy of the emitted electron. For de Broglie, every particle has a wavelength lambda equals h over momentum. The smaller the momentum, the larger the wavelength. For nuclear decay, n equals n0 times e to the power of negative lambda t. The decay constant lambda and half-life are linked by t½ equals natural log of 2 divided by lambda, which is 0.693 over lambda. Mass defect and binding energy. When nucleons bind together, mass is lost. That missing mass becomes energy. E equals mc squared. The binding energy per nucleon graph peaks near iron. Elements near iron are the most stable. Fission of heavy nuclei and fusion of light nuclei both release energy for this reason. Paper 5. Question 1 is a planning question, worth 15 marks. The structure is identical every year. Learn this template and you can apply it to any experiment. Step 1. Draw a labeled diagram of your apparatus. 1 mark. Step 2. Define the problem. State your independent variable, dependent variable, and at least 2 control variables. 3 marks. Step 3. Method of data collection. Explain exactly how you will measure the independent variable and dependent variable. Name specific instruments. State that you will repeat measurements and take averages. This is worth 4 to 5 marks. Step 4. Method of analysis. State what graph you will plot and what the gradient equals in terms of the formula. 2 marks. For example, plot t squared on the y-axis against length on the x-axis. The gradient equals 4 pi squared over g, so g equals 4 pi squared divided by the gradient. Step 5. One specific safety consideration with a precaution and additional detail like using at least 8 values and a wide range. 2 marks. That structure, every time, for any topic. Command words. This is where students silently lose 10 to 15 marks every paper by answering the wrong type of question. State means give one bare fact. No because, no explanation. Just the answer. 1 mark per fact. Count the marks and write exactly that many facts. Nothing more. Describe means say what happens, not why. For a graph, state the shape, key values and behavior at limits. For a process, say what happens step by step in sequence. Do not explain the cause the moment you write, because in a describe answer, you are wasting time for 0 marks. Explain means give the reason why something happens, as a chain of physics reasoning. Each step in the chain earns 1 mark. If a question says explain for 4 marks, you need 4 linked steps. 1 sentence earns 1 mark. Think. Cause leads to effect, which leads to the next effect. Use the words because therefore this causes and as a result. Define means give the precise scientific meaning. Exact wording matters. Missing 1 key phrase, like per unit mass or from infinity, can cost you the entire mark. Learn your definitions word for word. The golden rule, state is just say it. Describe is what happens. Explain is why it happens. Define is the exact meaning. Section B of paper 4 asks you to answer 1 optional topic worth around 30 marks. You should prepare all 4, then in the exam room read every section B question before choosing. Not just the one you revised most. Here is what each topic always tests. Astrophysics. You will need the Stefan Boltzmann law L equals 4 pi r squared sigma t to the fourth. Wien's displacement law and Hubble's law V equals hd. A very common question asks you to explain how the distance to a distant galaxy is measured. No standard candles and Cepheid variables. Medical physics, X-ray attenuation, I equals I naught EAS to the minus MUX. Specific acoustic impedance, Z equals RHOC. And how PET scanning works through annihilation, producing 2 gamma rays at 180 degrees. Comparison questions between imaging modalities are extremely common. Electronics, inverting op-amp gain equals negative RF over Rin. Non-inverting equals 1 plus RF over Rin. Know the comparator output. It switches between positive and negative saturation voltage. Communication, attenuation in decibels equals 10 log of P out over P in. The sampling theorem says sample frequency must be at least twice the maximum signal frequency. Number of quantization levels equals 2 to the power n, where n is the number of bits. Before you walk into that exam room, this is your checklist. Gravitational fields. Phi equals negative gm over r. The negative sign, always. SHM energy graphs. Ke, Pe, and total energy, all 3 on one diagram. Capacitor discharge. The shape, the formula, and why it is exponential. Paper 5, Q1 template. Diagram, variables, measurement method, graph analysis, safety. Command words. You know the difference between state, describe, and explain. And you have done at least one full-timed mock of each paper and marked it against the mark scheme. The mark scheme is the most important document you will read in these 14 days. More than any textbook, because it tells you exactly what Cambridge rewards. Past papers, mark schemes, repeat. That is how you pass. You have 14 days. Use every single one of them. Good luck.